Welcome back to Autodesk Inventor Automation Academy. I'm Philip Cox, and today we're going to be talking about iLogic assembly configuration. So we're going to take a little break from doing add-ins today, and we're going to jump into iLogic and show you how you can use iLogic snippets and iLogic rules to make a basic assembly configurator. So the example today actually comes from one of my coworkers, Cameron Wetton. Thanks to him, and we're going to kind of go through that. We've added a little bit onto it and excited to get into it. So let's talk about some iLogic snippets. So iLogic snippets are powerful ways to kind of get the same type of effects that you'd get from the Inventor API in iLogic rules without going through kind of the whole API. And so they hide some of the functionality they're doing in the background to make it nice and simple for you. So today we're going to look at iLogic snippets that help with adding components. And so you can kind of see on the screen over here, we have on the left, when you have an iLogic rule open, you'll see these iLogic assembly component, different like folders that hold the snippets in here, and you can double click on them and they'll place them into your code where your cursor is. Now, once you do that, you need to, edit so that it, is doing what you want it to do. But today we're going to be adding in components, and we're going to be constraining them. So when we add components, we'll need to have the path, a string that designates where on your computer that is. Now, if you're handing these files over to different computers, you want to make sure to locate them in a place that is going to be equivalent. Whether you're probably not going to put it here where I've put it on my users, Philip Cox, because that's not going to be the same if I passed it over to my coworkers. And there's different ways to do that. Doing it off of the C drive, having a folder that's going to be on your C drive. Another is that you focus on, go grab the path where your project file is, and then base off everything that way. So we'll need to get the path of where our files are. We're going to get several different documents, and we'll go look at this in Inventor here in a second. And then we'll actually use the snippets. So when we jump in, you'll see that we can add these snippets here. They'll have some generic values in them that will change around. You can see that we're making it, putting in the component name that will go in once we call it. We're giving it a path, which is this parts folder plus the part name that we want to go in. We're going to position it, and in this case, we don't care where it goes. We want it to go on the origin, so we'll put in nothing. And ground it. Other cases, we won't ground it. That's important to remember if you're copy pasting code, to whether you have the grounded set as true, because later when we try to constrain things, if it's grounded, that's not going to work. And then, of course, setting it visible and different things like that. We're going to look through different versions of how to add the components when we're looking at constraining them, or whether we're looking at placing them specifically and then grounding them there. So that's kind of what adding components is going to look like. We'll after we're done looking kind of at the full agenda, we'll jump into Inventor and look at it. So after we add the components, we're going to be looking at constraining the components. We want them to be able to be tied to different parts and origin planes and different stuff like that. So once again, we're going to be using iLogic snippets for that as well. And we have this folder called relationships where we're going to get those snippets. And so some of those will be add UCS to UCS. This allows you to basically do 3 flushes in one, flush constraints. So you can take a UCS or an origin and put them together. We'll also look at inserting, and with inserting, look at using named entities, but also the work planes and work features that are already in our parts and assemblies. And then, your basic flush and mate constraints and what those look like through the snippets. Okay, so with that, I'll go ahead and drag Inventor over here, and we see kind of a silly little assembly. Well, I mean, the base of it is an air engine. I've added this clamp subassembly just so we can have an example of a subassembly to play around with and that changes things a little bit. So let's go look at that code that we wrote up here. Go open up the iLogic, drag it over, and we'll walk through it together. So here, like I said before, we're setting up different folders that we're going to have the path to access. This might be looking at your project file and grabbing the path off the project file if that makes more sense for you. You can build up, the subfolders here. You can see I've made a folder that controls or contains all three of the different flywheels in there so that I can access it. But you can arrange this however it makes sense for you. Then, well, I mean, kind of some usual suspects here of getting the assembly document off of this document, grabbing the component definition from that, and we want to get all the occurrences here as well that we'll use later down. So some things, let's look maybe first, once we've kind of gone through that first stuff, let's look at a basic snippet. So I'm going to add this here so you can see the difference between the generic one and what I've edited here. So if I come to iLogic assemblies / components and double click on add component, we'll get this line here. And it's saying, hey, we have component A. This is just the variable name. And it's going to equal components.add. Then we get these different inputs. If we hover over add, we can kind of see what they are. So it starts out with name. And this is going to be the name of the occurrence component that you're adding in. So it's not like the part name or anything like this. This is something you'll choose. And you can see here up above that we've made a variable here called chassis component name. And we're going to title it underscore chassis. Underscore we're using here in just kind of a way of being like, hey, we're automatically adding this so that we can see that. So this can be whatever you decide you want to name that. However, we will be referencing later on, and that's why we've made a variable to make it easy. And we're not just pasting this string all over, which we do in other cases. But if we choose to change what we want this name, now we don't have to go change it throughout our iLogic code. So then we're going to reference the parts folder where this engine chassis part is in. So I've gone ahead and grabbed that path. For me, it's in this engine mount folder. And so the parts folder and then append with the / there to get the .ipt. Now, we're just going to leave the position at nothing. This can be a matrix, but it's not an API matrix. And we'll look at that when we get to the subassembly. But here, if you leave it as nothing, it'll put it on the origin with no rotations, which is fine. That's what we want. So since it's there, we're going to go ahead and ground it because it's the first component we're putting in. Everything's going to tie to it. And we'll leave visible as true and appearance as nothing. So you can see kind of, we didn't touch any of these. We mainly changed the name and the path that it was coming from. And if we go, we got a good amount of code here, but I'm going to comment it all out. You can see what just that line is doing here. So if I hit and I'll delete all the stuff in here. Nope, that bolt didn't want to be deleted, did it? Because we deleted the pattern. Where'd my delete go? There we go. Now when we hit run, boom, you can see it's just dropping in the chassis. Now, one great thing about these snippets is we'll show you on the flywheel. But when you, because of how the snippets are, let me open this back up. Oop.
Real quick, before we keep going, I just want to see if this is useful for you. We just ask that you please like and subscribe. You know, the feedback that you give us is very helpful when it comes to creating more content like this for teams like yours. So without further ado, let's jump back in.
Come on, edit rule. There we go. As long as the component name is the same, if you run this again, it will actually do a replace. Now, you won't see it on this one because we don't have a different chassis part to swap out, but we'll do that with the flywheel, and you can see how we're not having to delete and add again. The add actually takes care of that replace. So I'll go and uncomment all of this stuff here. Comment it out. Oh, I hit comment. So let's come here. There we go. Okay, so back here, now we're going to place the axle. Nothing really is different on this one. We're just going to add, besides the fact that we're not grounding it here, because we're going to want to constrain. So we give it a name, this time underscore axle, parts folder, engine axle, non-grounded. And we're going to do this one, UCS to UCS constraint. So UCS to UCS, that means that we're going to, we'll first give the constraint a name. So that's axle to chassis. We just, you can name it Bob if you wanted to, probably not a great name, but here we'll name it axle to chassis. Then we need to reference the first component's name. And so that's where this variable comes in. We could just paste underscore chassis, but we'll use the variable because that's better coding. And then this next one is an entity name that we want to use as the constraint. So here you see that component 1 and UCS name. Now UCS can be the user-defined coordinate system, or it can also be an origin. In this case, we're just going to use the origin. So we'll just type in origin, and the same thing for the axle. We want the chassis origin to go to the axle origin. But if we came in here, let's just hit save and close, and actually put in a UCS somewhere, we could use that UCS's name. So go back in, and that will get us the axle. Now let's talk about the bushings. So the bushings, we're going to do a little something different, and that's going to be using named entities. Named entities is a relatively new thing in the last, I don't know how many years, but it works with attributes in the background. Inventor has had attributes for a long time. However, the named entity gives you kind of a built-in, easy-to-use interface to use them, and the iLogic snippets take advantage of that quite nicely. So here to first add the component, nothing's really going to look different. We give it a name. You can see I didn't make a variable this time. And then give it the parts folder plus the name. That gives us our path. We're going to just leave it placed on the origin. We're not going to ground it. Same thing here. But now we need to add this insert command. Now the insert command wants, once again, a constraint name, a component, then it's asking for this entity name. So there's the chassis component name variable that we used before, and we're passing it in this left bushing edge. just in the string. Now, what is that referring to? Let's go look at that. So I'm actually going to run the build just so that I can easily grab that bushing to here. But let's look at the chassis first. So if you come down here by your iLogic, you'll see the Rules tab. You'll also see this Entities tab. And here, they're hidden right now, but I have two entities. And if I make them visible, you'll see kind of this green arrow that's pointing to that edge. And how did I do that? Well, I've come in and I'll do the outer edge here so you can kind of see. You got to click on it first and then you right click and there's this assign entity name. And of course it opens on the other screen, but here's our entity name and I can say left bushing outer edge here. And this will add a entity name there. And what is this doing? Well, it's actually adding an attribute that has the attribute set and name of the attribute set as entity name or something like that. And so the only attribute thing that you're editing here is the value, which you set as this name. That's on the back end. For us, we don't really care about that right now, but just so you know, that's what it's doing. But it gives us this entity name here, and we can use those in our iLogic snippet. So if we open this up here, that left bushing edge, it knows to go find that if we, copy exactly what we typed in that name there. So we can say in the chassis, we want the left bushing edge. And then in the left bushing, so this is the same here, we want one called bushing edge. And if we go look at the bushing, you'll see that we have an entity called bushing edge right there. Okay, so we've got those two parts. Zoom out, go to the build. So we have the chassis left bushing edge with the bushing and its bushing edge. Now notice this is referring to the actual, not the part file, but the component occurrence name that we placed here. That's important because we're going to do the right bushing next. So we'll add the right bushing just like we did the left bushing. And then on the constraints, we're going to get the chassis, the right bushing edge, because we want the right one. And then we do the right bushing, and it's referencing that same bushing edge, but it's on the right bushing occurrence. So a couple things that you'll notice about these insert commands, you have a couple different things, like you have axes opposed, you can flip it to false and true that way to flip the thing around. You've got a distance offset, got lock rotation. In this case, we're doing a press fit, so we want the rotation locked. If we didn't, you could set it to false and then it would spin. You also have these bias points, which can help when you have multiple solutions that are valid or how these things look up. You can put a point on one and a point on the other and then call them out, and it will do the solution where those points are the closest. So just some additional options that we're not going to play with right now, but you can see their usefulness. So once we get that in, then it will be adding the bushings in the correct place. So now if I go ahead and comment out down here, and we delete all of this, and the remaining bolt, and run it. Oh, I left the axle in there. Oh wait, I think the axle came before. Yeah, you can see that we're getting those bushings put in the correct location here. I'm going to go and turn off those entities so they're not in our face this whole time. Turn off visibility. There we go. And that one we left invisible anyway. Okay, there we go. So now let's do the flywheel so that we can see kind of the swapping of parts that we talked about. Come back up here. And uncommon. Okay, so first thing is we're going to be dealing with different parts. Often in these assembly configurations, what you want to do is swap out parts based on, different inputs that you're getting from, um, I don't know, a user input like a form, or let's say you're getting something from a, outside source that you're going to run this on. Um, so here we need to make a select case that's going to based on a different rule. And I've set up a parameter here. This one's called flywheel type. Will give us the different path to where our we want to grab the parts. So here we set up a variable, a string variable. We're just going to default it to the default one, just in case something weird happens, and we just like having a valid solution to start with. Then the first one, if that parameter is basic, we're going to give it default. If it's spoked, we'll give it the underscore spoked. If it's holy, then we'll give it the underscore holy. Once again, these flywheels are just kind of silly, but it'll show the swapping of parts. Then we need to do the add components. And this is pretty straightforward. We're going to name the thing underscore flywheel. No matter what part it's coming from, we're going to name the component occurrence underscore flywheel, and that will allow us to do that replace effect. Once again, we could do this with a variable so that we could reference it later. Then we're going to reference the flywheel folder we set up here and add in that flywheel doc name that we just made there. And you can double check them to make sure that you've got the right backslashes and appending correctly. Once again, we're gonna just leave it at the origin, not ground it, because we're gonna constrain it. So in this one, when we constrain it, we're gonna use a flush and a mate. We're doing this, we're not doing UCS to UCS because we want this thing to spin. So we'll have the axle component name referencing that axle that we're going to put this flywheel on, and we're going to grab the YZ plane of that. And this is just straight the name off of, if you're using a different work plane that you created, you'd put that work plane in there. You could also use a named entity like we did for the bushing and reference it that way. Then we're going to get the flywheel that we just added and get its YZ plane. And this also brings into focus the importance of being consistent in how you build your parts and subassemblies and where those origins are, because it's a whole lot easier if every flywheel is made the same way, because then I don't have to worry about like, oh, oops, somebody made the flywheel on the XZ plane or whatever. And now I have to, type of like, if you're using this flywheel, then you need to constrain it in this way. So it makes automation so much easier if you're consistent in your modeling habits. Then we're going to offset equal to 0 and no bias points. Now we're going to mate the axes together. So we'll add mates. We'll name it whatever we want the constraint to be named. We're once again going and grabbing the axle comp. We're going to get that x-axis, and off the flywheel, we're going to get the x-axis again. Straightforward and simple because we're modeling them in such a way that they're going to share an axis that way. Now, offset 0. Now, there's some different inference types, and if you go and look at the constraint, which we'll do after this, you can kind of see the difference of, the inference type. Here, the solution type of K no solution versus, here, I'll show you the different ones here: K-aligned, K-no solution, K-opposed, and K-undirected. And then we're not going to use the bias points. So now if we run this, after we delete away stuff, hey, let's pause for a minute. Who are you working with for your Autodesk tools today? If you're already learning from us, it might be worth a conversation. At KETIV, we back it up with strong support, a smart, easier renewal process, and deeper expertise across the automation, data, and simulation. If you're open to it, we'd love to work with you. Okay, let's get back to learning. Oh, helps if you run the correct rule. And then there's our flywheel. And we can change the parameter. And we have the rule suppressed, so it won't run the rule right when you change the parameter. But you can see that we run the rule that way. Now, I've actually made a form to kind of handle this, which is a thing you can do. Where here, now I can select and hit build. It'll run the build rule, and you can get the different versions here. And you'll notice we're not deleting, it's not reordering. I mean, the flywheel's last on this one, but it's just replacing it in the tree. So if you haven't seen forms, there are probably other previous videos that go into doing an iLogic form. But here I'll open up the edit form, and you can see that you just add in the different parameters that you want. You can drag them over here, and it will give you the different types of inputs. You can click on one and do some edits down here in the documents. But usually it's just to drag over the parameters, and it's going to give you what you want. Here we have a control type of as a combo box. You could set it as a list box or a radio box. But that kind of gives you an idea of the forms. Okay, let's go back to the rule. Open it up. We've done swapping out parts. Now let's say you have some hardware that you want to put in it, and you're either using Content Center, or you don't want physical representations of your hardware because that's going to be less performant. You got a big assembly and there's a bajillion screws in there and washers, and you don't want to physically represent it. So you want to do virtual components. So here we're going to look at both those two options. So first, I'm just doing a cleanup here of going through all the component occurrences and deleting any virtual component. For this demo, that works. Probably want to be a little more elegant if you were doing it another way. Maybe you want it to delete out all the virtual, because we're going to put them all back in if it's virtual. Then we have this parameter called hardware representation that can be physical or virtual. And so if it's physical, we're going to go get a content center part. And this is, if you can go find this over in iLogic Assemblies component, add content center part. And I'll double click here, and you can see that it adds two. Now there are two different ways to do this. One is giving it the designation here, and it'll make sense more when we go look at Content Center. But there's a column called designation, and if you give it just that string, it will go and grab that. Now you need to put in the family. If we hover over here, you first put in the Content Center path, the family name, the designation, and then you can get to where you want to place it and whatnot. And this other version, you add that family name, and then you have the designation here, but the designation is just an array of strings. And so you actually can do a paired, a coupling here of the designation or the column name, which this one is designation, the value, and then another column name thread length and the value. So this allows you to be more specific of if calling out the different values. And this can be helpful because the designation between different content families, content center families, the nomenclature and how they put them together is based off of whoever uploaded them. And so it might not be consistent with how you build your little string builder here to make it work. So if it's more helpful to be able to call out other values to make sure you're specifically getting the one you wanted, this is how you do that. So anyway, I'm going to delete those two, and we'll go look at Content Center to see kind of how you come up with these strings to get you down to the family and the designation name. So we'll go assemble, place from Content Center. So here we're getting a round head under fasteners, bolts, round head, and then we're getting the crossed recessed pan head machine screw. And so you can kind of see some of the names that are going to show up there. And then once I double click and place one of these things, you can see that we have thread description, nominal length, thread type. But if I look at table view, here you see that designation column and the strings that would show up there and the other different columns that you could reference in the second version that the snippet gives you. And so this allows you to pick out the exact one that you want. You'd obviously put in some logic that based on, whatever your assembly configurator needs, you're going to go grab the hardware that needs to be put there. So that is, I hit OK and not cancel. So cancel. Get placed in? Doesn't look like it. So now if we run the build rule, you'll see we place the 4 screws there. Now, one thing that I didn't talk about is the pattern. So let's go look at the pattern in there. Here we have a rectangular pattern. I believe the snippet, yeah, there it is. It's under iLogic Assemblies Components. We drop that one right in there. We are going to give the pattern a name. In this case, I'm just calling it bolts. We're going to call out the component that we want, which we named chassis bolt 1 right up here. And then we are going to give it a column count and a column offset, which is this 2 and 2.5. And then here, we'll give it the axes or the entity we want it to pattern along. We have the column natural direction equals true. And we have row count. So we had our column count. Now we want row count equals to 2 and row offset of 5. And then the entity name that we want to go the rows along, and whether it's the natural direction, so you can flip it or not. So that will give us our rectangular pattern. Now, one thing I kind of skipped there was assembling, and Content Center parts have iMates in them that allow you to use iMates in your assembly. So we're going to use the add by iMates relationship here. The snippets, there we go. So add by iMates. And that's going to give us this call that's going to ask us for the constraint name again, the component 1 name. We're going to put it to the chassis, and then the iMate name, and then once again the second component and the second iMate name. And that will give you those iMates there. Okay, so and we saw that work here where we're patterning in, but what if, let's go back to the form here, what if we want virtual components? We'll do that, deletes out all those components, and you see we have virtual components here. If we come in and look at their iProperties, tried to open it up on the right side. Notice that we can edit the part number and the description, different I properties we're allowed to. So how do we do that? Well, let's open up the rule and look at it. So here in the else, so if we're not a physical, which means we're virtual, we're going to delete out the patterns and the component that we had there. And then we're going to set up the occurrences. I think this is double up here. I already did it up there. I'm just using different names. But we need to get a matrix because we're going to place these virtual components by matrix. However, we don't care where they go. Maybe you want your virtual components to be where they would be. In this case, it doesn't matter because they're just, virtual components in there. So we're just going to leave it at the identity matrix, but you can do the rotations and translations. We'll show you an example of doing that on a part in the subassembly. But there's our identity matrix, and then we're going to make a string name for the part, a virtual part name. We're going to dim up our virtual occurrence. So here's our component occurrence equals occurrences dot add virtual. Now we pass in that name we want it to be and the matrix, which is, in this case, just an identity matrix. Then if we want to set our virtual component properties, we're going to call iProperties.value. Then we have to pass in the name of that component right there. So we have the virtual component 1, and we'll do, we want to grab the project tab, and those iProperties, it calls it the set name here. And then we're going to grab the description and the part number properties. And then we set them, I've set some description and I set the part number to the name that we're giving it. And then here we just are going to make 4 versions of that. So I set the quantity of 4, and then I for loop through it, starting at 2 because we already have one. And that will copy those virtual components. So just an example, done simply. You can go more in depth with this, but of how you'd add a virtual component for your hardware here instead of using Content Center. Or perhaps a library of hardware that you have. Okay, so we already saw that working. We saw the virtual components. What left do we have here to go over?
Hang on one sec before we keep going. If you've been following along, this is the foundation for creating automation. When teams put this into practice, it adds up fast. Oldcastle infrastructure is one example, reducing layout times by 80%. If you're ready to go from baby steps to full working solution fast, go to ketiv.com/automation to see how we can help.
We have adding a subassembly. Now, adding a subassembly, you might think, oh, that's going to be different, but really it's not. A subassembly is just another component. So here we're just going to name it subassembly 2, and we're going to grab the assembly folder. So I put it in a different folder here, and we're going to call out the assembly. And then we have the position, grounded, the same type of things. Now, constraining the subassembly is a little different. We're going to add constraints, and I guess if you're constraining to origins and different planes and stuff, you're not going to do anything different, right? You're going to grab, we want to constrain this thing to the chassis. Let's say we're constraining the XZ plane to the XZ plane in the subassembly. We would just have the subassembly name here, and then, oh, here's a good example, subassembly name, and then we'd have the plane or the work feature. I think I named this one a work feature XY placement plane there. So that looks very much like what we did for part components. However, if you want to use features that are inside the subassembly on one of the parts, so kind of diving down in, you can do that. You just need to make an array of strings to get there. And so here you see the squirrely brackets, I like to call them, to make our array divided by a comma. So the first string entry is our subassembly component name. And then inside of that subassembly, this is the component name of the next part. And if you wanted to keep going, you'd keep going. But we're going to go grab the bottom clamp occurrence, and inside of that, there's a top of bracket clamp plane that I've made that I wanted to go grab to add the flush there. So we have that flush, and then we're doing the more simple one of just grabbing something on the subassembly. So these are two named planes that I've made. And then the last one, we're just doing two origin planes. So you can kind of see the different gambit here of using an origin plane that part starts with, naming your own planes on the subassembly, and then diving down in to grab a named plane here. I didn't use a named entity in this case, but you could do the same thing with a subassembly part if we were grabbing that bushing edge inside of a subassembly. Okay, so if we save this and run it, I guess I can just click here. You'll see it it flickered there, it placed it, and then constrained it over here. And you can see those planes that I made up inside the different parts and subassemblies. Okay. So now let's talk about, well, actually, let me pull up that form. Let's talk about some other things that we're doing in this assembly besides just placing components and constraining them. You're going to want to have parameters that you push throughout. Now here I have some very simple examples of pushing parameters. One, I have a type, so this screw top. Here I have two different forms. Basic. Oh, something's not working right. I'm gonna go check that. Which will have just a straight and then an X form here. And then we also have a hole diameter that we can update as well to change here. So let's go look at those forms here. So we have in the build, I guess, oh, yep, that's why it's not working. We need to run this rule called push parameters. So what does push parameters do? Well, this is a rule that we've come up here with KETIV that does a lot of work for us. And in this case, it allows us to push parameters from the top assembly down into subassemblies and into parts underneath them without having to have linkages between upper and lower parts so that we can swap things out and not worry about breaking those linkages. So here we're just going to for loop through all the occurrences in the assembly, and then we're going to be looking at the top level parameters and looping through those and checking with the children. So we're checking the parents' parameters against the children parameters, and if any of them match names, then we'll update the child parameters to match the parent. And so that allows you to, based on the naming matches, update those parameters all the way down through. And then if you have a build rule, it will run the build rule in the part or assembly. So that lets us set up kind of it to configure subassemblies as it goes. Now, one thing I did add into this is for it to not run on virtual components because we were placing virtual components and was trying to run build rules on virtual components, which of course didn't exist. Okay, so let's go look at the subassembly. And well, let's first look at parameters here. So we've looked at these before: flywheel type, hardware representation, screw top type, and hole diameter. So as we get down into a subassembly, you'll notice the same names, and where they aren't the same, we will not get an update. from that push parameter rule there. And so that's how we update the parameters. And then, like I said, it will run the build rule at the end. And in that build rule, guess what we run? We run another push parameters. That's in this subassembly to push down to the parts. Okay. Now, while we're here, one of the things that we haven't covered about those iLogic snippets for adding components is what if you want to add a component and place it in a specific place and then ground it, and you don't want to necessarily constrain it. How do you make that work? I mentioned using a matrix and whatnot. So let's look at that example right here on placing the bottom and top clamp for this little subassembly here. So placing the bottom clamp, we just place it and ground it like normal. Now for the top clamp, I wanted it offset a little bit, and I didn't want to use an offset on a constraint. I could have done that, but in this case, we're just going to place it and ground it. Now, how to do that is we need to make a matrix. Now, the iLogic snippet of the add components takes a matrix in the position, but it's not a normal API matrix. It's what's called a document units matrix. And it has its own hierarchy of different things that it needs from a different type of, it's going to be like document units vector and stuff like that. So since we're more used to working with the Inventor API, we're going to find a way to translate between those things. So we're making our, as I'm calling it, the normal matrix. We're making a translator vector that's going to keep it the same in the X, but in the Y here, 0 in the X and Z, and in the Y, we're going to go up the chassis thickness and the clamp thickness to just get up that offset. So there's our translation vector. Now you'll notice that I have currently this Y-axis vector and the rotation commented out, but you can add in that rotation if you wanted to rotate it. You do that before you translate it. And so here we have math.pi over 4 to give us a 45-degree rotation about the y-axis that we've made here, and we're going to do it around the origin. So then we set our translation after we do our rotation if we want to around that translation vector. Now we have a loaded, fully ready normal matrix that if you try to put into the snippet, it will fail. So how do we handle that? Well, we need to go get it plugged into the units or the document units matrix. And the best way that I have found is getting it this get matrix data, which gives back a cells as an array of double. So it's going to be a 4x4 matrix, but we'll make that, and this is kind of it'll get you if you're not paying attention. You need to dim matrix cells and put a 15 here. That's a 16 size matrix because of the 0 base of doubles. And then you need to pass that in by reference, and you'll be hinted by that by ref call here. So I don't know why this wasn't a function and just passed out the matrix, but that's how they decide to do it. So you need to pass in this empty 16 or 4x4 matrix into the get matrix data called off the normal matrix, and that will pass back out this matrix cells filled with the right values, and then we're going to plug that back into a new document units matrix, which we're going to make, which we need to pass in this application and the type of units that it is, which we can get thusly from iLogic, this application, and then grabbing the document, typing it as the assembly doc, and getting the units of measure off of it. So then we have that I'm calling example matrix, the document units matrix, and we can call put matrix data off of that and pass in that matrix cells that we got from our normal matrix, the API matrix. So once we get all that done with the matrices, then we can use that one to plug in the position. And so all that's doing is offsetting it how we've set up that translation vector that way. And then we set grounded to true and set there. So if you want to use the snippets to and matrices to place components where you want them, sometimes that can help with if you're going to constrain them, get the right solutions. If you're not having luck with the bias points or different things like that, that's how you do it. Okay, and then you see kind of what we did with the flywheel here with the screw top, where we have the normal one or the X one, and different constraints, different things. And then we're doing the same thing with the screw, different sizes. Let's say you have your own library of hardware and screw sizes here. This is kind of an example to emulate that, where you'd swap out the different screws and place them that way. So now, when we come back here to the assembly and we pop up the form, we can swap these around. Let's go back to physical. We can change this to basic, keep that at 0.5, and we'll see, boop, it update as it runs that push parameters rule, which runs the pushes all the parameters down to their like named parameters in the children, and then runs any build rules that exist in the children. And those build rules can subsequently run a push parameters. It does down to their children. So you get down into the parts like the screw top. And in that way, I mean, this is a simple example, but you can build up a iLogic assembly configurator where you can swap out parts, you can push parameters all the way through. You're not worried about breaking linkages, and can be very useful. So hope you enjoy that and take it to the next level. Thank you.
Let me pause for a moment before we continue. If you're enjoying this course, what you're seeing here is really the starting point. We've worked with teams like Oldcastle Infrastructure to turn concepts like this into real measurable outcomes, including an 80% reduction in layout time. If you want to fast track introducing automation to your organization, reach out to us and get started at ketiv.com/automation.